Hey everybody, Vade here, and today we are going to be discussing a not very actually, a quite tricky concept in limits, and that is descriptive limits, or limits which we can say equal to plus or minus infinity. Now, let's take a limit like this, for example. The limit as x approaches negative 4 to the left of x over the absolute value of x plus 4. So if we try to directly substitute 4 into this here, we get, or negative 4 into this, we get, and we're going to draw a thought bubble here. This is just going to be negative 4 over the absolute value of negative 4 plus 4, which will then just be negative 4 over 0. So because of this, we can then say that this will be does not exist. But what if there was kind of a better way of saying this? What if there was a better answer that just does not exist? Well, let's kind of think about this. This is the, let me rewrite this here. This is the limit as x approaches negative 4 to the left of x over absolute value of x plus 4. So what do we mean by negative 4 to the left? We mean right to the left at negative 4 of negative 4. So this could be like approximately negative 4.00001 or negative 4.00000, whatever. It'll have infinite leading zeros. So for simplicity here, I'm just going to use negative 4.001. Okay? And so if we kind of directly substitute this negative 4.001, which is right to the left of this negative 4 here, we'll then get negative 4 point, I'm going to draw a thought bubble here, I don't know, negative 4.001 over the absolute value of negative 4.001 plus 4. And so what we see here with the numerator is that this will be a negative value, right? Negative, and then 4.001 is negative. And then absolute value, right, of negative 4.001 plus 4, that's going to be, that negative 0.0000 whatever 1. And that's going to then be absolute value of a negative is positive. So this is going to be positive. So what you see here is that this is negative over positive, which is just going to be negative. So because of this, we can say that this limit is just going to be negative infinity. Okay, that kind of seems weird. Well, if you really think about this here, this has a discontinuity at x equals negative 4. It most likely has a vertical asymptote. And so what we're seeing here is that, we look at the left of negative 4 here, right? It's going kind of towards negative infinity in some sort of way, right? If this is like negative 4 here, some asymptote, this is going to negative infinity. This is what we're kind of seeing here. So instead of saying does not exist, negative infinity is just a better answer. Okay, hopefully this kind of makes sense. Let us go ahead and do another problem, but I want you to pause the video and try this one on your own. So it's the limit as x approaches negative 1 to the left of x minus 2 over x plus 1. So I want you to pause the video and see, do we even need to use descriptive limits? Can we just directly substitute and just get the answer, or not? Well, hopefully the answer is obvious. But anyway, to that question. So pause the video, try it, unpause when you're ready. Okay, hopefully this was kind of straightforward, very similar to the last one. So what we need to do here is, first of all, if we directly substitute, this should be kind of obvious. Of course, if you're, in a testing environment, unless you're supposed to identify this kind of step, I would just eyeball it for the most part to save time. But if we just do x minus 2 over negative 1 plus 1, that'll just be x minus 2, or sorry, if we just do -1 minus 2 over -1 plus 1, that's just going to be -3 over 0, right? And so, and we see here if we have -1 directly, and x plus 1 is the denominator, we can't cancel. It's not a whole. This is a rational function. We know that there is absolutely a vertical asymptote at x equals -1. And so we need to see kind of the behavior of the function, right, to the left of -1. We're trying to describe that behavior. So while yes, this would just be does not exist, we could have a better answer for this because we want to actually know the behavior of this function right here to the left of -1. Okay, so what we need to do here, right, the left of -1, that's going to be like, again, like -1.00001. For simplicity's sake, I'm going to use -1.001, kind of like before. And so now if we kind of, quote unquote, plug this in here, I'm going to thought bubble because, it's not really correct math notation. That's when I put a thought bubble. So we see here, if we plug it in, -1.001 minus 2 over -1.001 plus 1. And so we see here in the numerator, it's going to be a negative value. And in the denominator, it's actually also going to be a negative value, technically, even though, negative, if you think this was -1, this is really close to -1 would be 0, but technically it's a really small negative value. And so we know that negative over negative is going to be positive. And so because of this, this is going to yield to positive infinity. And so once again, if we see, again, the function here, right, it's going to be a rational function, but at -1, we'll know here with our vertical asymptote that it's going to go to, positive infinity. And so, yeah, I mean, descriptive limits are really useful because instead of just saying does not exist, we actually get a better answer that tells us what's kind of going on. There's a vertical asymptote there. We get it. We understand, but what's going on around that? And so it's a useful insight. So hopefully this kind of makes sense. It's just picking values really close. Like if you think about to the left, pick something that's really left. If we think about to, again, like to the right, pick a value that's really right. Like if we had something like limit as x approaches -1 to the right of x minus 2 over x plus 1, or over x plus 1. Did I say x plus 1 here? I would say pick something like -0.9999, something like that, or even simpler, -0.999, whatever, right? You get the point. And then plug it into, numerator, denominator, see the signs, and then determine if it's going to be a negative, just, negative over negative, positive over negative, negative over positive, positive over positive, whatever. And then you can just slap an infinity sign. That's essentially what it is in short. Hopefully this kind of makes sense. Pretty hard to understand. When I first learned this, it was pretty tricky, but hopefully this is a good explanation.